Hi, everyone. My name is Huey Han. I'm a product manager from Amazon S3. And today I'm here to talk to you about building a scalable, performant data lake on Amazon S3. So before we get started, just going to take a quick look at what we're going to cover today. First, we're going to talk about a brief history of what led to the data lake architecture we're seeing today. Then we're going to talk about some specific recommendations about building a data lake on S3. And specifically, we're going to talk about some recommendations around the performance aspect and the cost aspect. So let's get started. Let's take a quick look at the brief history on data lake. It all got started in the early 90s, where a lot of companies back then began to realize the value of data. For a lot of companies, they realized that data can be transformed into insights. Insights about how to optimize your operations, insights about how your customers are using your products. And these insights drive better decisions for these companies. And these decisions in turn into competitive advantage in the marketplace. So because of that, more and more companies begin to leverage data, and gradually a technical stack emerged for this kind of analytics workloads. And for this stack, typically these analytics jobs were done on an ad hoc basis against production databases. And these production databases back then are typically a transactional relational database run on a mainframe. And this approach worked pretty well for a while. And then what happened was data continued to explode as companies began to realize the value of data and they began to collect more and more data. And within companies, the personas using the data also began to explode. As people realize the value of data, whether you are in sales or in operations, you realize data can just drive better decision making. And on top of it, data-centric companies began to grow faster on average because of their distinct advantage of leveraging data, making better decisions in the marketplace. So as data continue to grow and scale, this leads to many issues on the traditional analytics stack of doing ad hoc queries against production relational database. Analytics against these databases can overwhelm them, causing performance, and more importantly, data integrity issues. So what happened then is that in the early 2000s, a new kind of architecture emerged to address the problem of the previous generation. And this is where the famous ETL came to be. And ETL is short for extract, transform, and load. And the idea is that rather than querying against the production transactional database, why don't we do analytics separately from the transactional database and load the data into a second data store specifically designed for analytic use cases. And this is where ETL is born, where raw data from transactional store is extracted, transformed into more analytics-driven, more analytics-friendly tables, and load them into the second data store. And along with this kind of ETL architectures, many innovations and concepts began to emerge, where the concept of OLAP appeared. OLAP short for online analytic processing, as opposed to OLTP or online transactional processing. And along with these concepts, there's many innovations such as multi-dimensional models, analytics queries, real-time pivot tables. And this worked quite well for a while. And then the same story began again. Data continued to explode, personnel using the data began to explode, data-centric company continued to accelerate. And this again brings a lot of problems for this ETL stack. Specifically, the second analytics store has limited scaling capability, but it's typically running on a single computer, a mainframe, on-prem. And as the data grows, it begins to get overwhelmed again. And this is where Hadoop come into picture. In the late 2000s and early 2010s, Hadoop just offers a drastically different way to scale. Instead of scaling using more performant computer, what we now refer to as vertical scaling, Hadoop allows you to scale horizontally by adding more parallel processing power or parallel computers. And moreover, these computers can be commodity hardware, very cheap and easy to procure, and it doesn't have to be the really expensive mainframe. And this new architecture really brings a lot of new scaling capability to the big data world. And on top of it, a very robust Hadoop open source ecosystem began to emerge. In the core of it, you have MapReduce and HDFS, which is the compute and the storage layer of Hadoop. But on top of it, you have ecosystem like Hive, Pig, HBase, all these different frameworks that allow you to plug and play your stack depending on your specific use cases. So this infrastructure worked really, really well for a while. But the same story began again. Data continued to explode and brings a whole problems to this kind of HDFS Hadoop ecosystem and approach. One, it's very expensive to store data. So HDFS is typically run on block storage, and block storage can get really expensive, especially if you run it on premise. You need to provision it ahead of time so that you don't run out of space. But getting to the right utilization ratio, that making sure that you're not leaving too much on the table, but at the same time, not running the risk, constantly running the risk of running out of space, is really tricky. And on top of it, HDFS has a scaling limit, about 5,000 nodes or 20 petabytes of data. As data continued to explode, a lot of companies began to hit that scaling limit. And last but not least, for HDFS, you need to scale compute together with the storage. And compute is really expensive, which means your Hadoop clusters become exponentially more expensive as the amount of data continue to explode and continue to scale. So at this point, we see the story of data continue to explode over and over again. So what do we really need? What we really need is a centralized repository that allow you to store all your data, whether it's structured or unstructured data, at any scale, durably and at low cost. And this is where S3 comes into pictures. As it turns out, S3 specifically addresses all these problems. First, for scale, you can put as much data as you want to S3, and things just work. You don't have to worry about hitting scaling limit again, getting to the right utilization ratio. And for cost, S3 is also really, really low compared to other storage options. You pay for only what you use. There's no provisioning required and no sort of calculations and doing financial model ahead of time. And durability. So S3 is really designed for store objects very, very durably, and you can expect most of your objects to be in S3 securely and durably for a long time. So as a result, because of these benefits that S3 offers, in the 2010s, we see a lot of Hadoop and big data customers begin to decouple their compute and storage and begin to replace HDFS as the storage layer for their data lake. And this is where we are today, where S3 is the central repository for your data. And you can put any amount of raw or production transformed data in S3. And on top of this storage layer, you build analytics and compute infrastructure on top of S3. So with that in mind, it's sort of a brief history of how we got to where we are today. Let's take a look at some concrete recommendations about building a data lake on S3. And specifically, we're gonna revolve our talk about, on one hand, performance, on the other, cost. So let's start off with performance. S3 is really designed for huge scale. So we offer 3,500 put, copy, post, delete requests per second, and 5,500 get head requests per second. And all these limits are set on the prefix level. And you can think of prefix as a part of your object key, including the slashes, that leading up to the object name itself. And S3 automatically scale to your request rate. So if you have consistent high request rate on a single prefix, S3 will automatically scale in the background to handle that high request rate and enable you to have more TPS on that prefix. Now, because the TPS or transaction per second is set on a prefix level for S3, getting the prefix naming right can really optimize your performance. So let's take a look at what a typical prefix design would look like today. A table today is typically really, really big. It could be tens of terabytes, 100 terabytes, or maybe in petabyte scale. So these big tables typically partition into smaller chunks so that it's easier for the query engine to handle. And the partition scheme most frequently used today is timestamp. So we have an example here where the customer is uploading batch process their data and upload to S3 and using datetime as the partition. And for each partition, as you can see, is further divided into different parts in different prefix using Parquet file format. However, this common prefix naming, there's a problem. And the problem is that if you suddenly, let's say you finish batch processing your new partition for today, March 14, and you suddenly start sending a lot of new files to S3 all at the same time. Because this prefix, the 0314, is a new prefix, S3 doesn't yet have the time to scale on the background to handle that kind of request rate. As a result, you might run into throttling issues with S3. And because of that, there is a way to change your prefix naming to handle that problems. And one way to address the problem is to add entropy or randomness to your prefix design to distribute that load across different prefixes. And specifically, you can add a random hash as part of your prefix before your partition name. As you can see here, there are sort of 2-digit hashes right before the partition scheme. And what this prefix naming can do for you is that then, let's say when you suddenly finish batch process your new partition and start sending a lot of objects to S3, they will be distributed across different S3 prefixes because all these prefixes has a slightly different name with that random hash. And what that means for you is that on a net basis, for that new partition, 0314, you have higher TPS limit, and this allows you to scale better. So besides prefix design, we also recommend you to look into other services that can complement a good S3 prefix design. So Amazon EMR is a good example where it does a lot of optimization for you under the hood because EMR really understand how S3 works. And on top of it, we also recommend you to look into some of the new sort of rising, getting more popular open source table formats like Apache Iceberg, Apache Hudi, that's use a Metaphase-based to organize the tables. And all of these new open source framework also does optimization under the hood for you. And they're specifically designed for cloud, for object storage. So let's move on to the next part of practical recommendations. We're going to talk about cost, how to cost optimize your data lake on S3. So on a high level, there's roughly 2 approaches for cost optimization on S3. First, if you know your access pattern really well and you want to build your own cost optimization mechanism. And the second approach is if you just want to automatically cost optimization strategy managed by S3, you don't want to come up with your own sort of mechanism. And for each of these two approaches, we have a solution for you. So let's say you know your access pattern really well. S3 offers you a ton of flexibility and a ton of storage classes specifically designed for specific usage patterns. So for example, if you expect your data to be frequently accessed, quote unquote hot data, you can use S3 standard, which is tailored for frequently accessed data. On the other hand, if you have sort of cold data that you don't expect to access very frequently, you have a variety of Glacier storage classes for that kind of cold data. And depending on how infrequently you expect to access that data, I mean, once a year, almost once every couple of years, there's different Glacier storage classes for that particular access pattern. What this means is that for all these storage classes give you the flexibility to design specific storage class for your specific segment of your data. Now, besides the different storage classes, we also offer you a lot of features to complement these kind of storage classes and make it a more managed, more easy experience for you. First, we offer you a S3 storage lens, which provides over 29 storage usage and activity metrics that help you drill down your usage and activity patterns. And you can see the drill down by region, storage class, bucket, and prefixes. And more importantly, it gives you specific recommendations for how to increase your cost efficiency, how to protect your big data. So you don't have to go through the documentations and try to figure out what kind of action you should take. And last but not least, Storage Lens is free to try out. So you can go back today and see for yourself if Storage Lens is something can provide value for you and if you want to use for your cost optimization mechanism. And the second thing is S3 Lifecycle. So S3 Lifecycle gives you a managed way to transition your data between different storage classes. Once you set up the policies, S3 then automatically transition objects between storage classes based on that policy. And the policy is really flexible. It can be, for example, number of days, number of versions, et cetera, et cetera. And once you set up the policy, you don't have to think twice about it. S3 Lifecycle runs on autopilot and it manages that transition just for you. So what we just talked about is sort of the first approach to cost optimization, where you want to drill down to your access pattern and you want to have a very customized cost optimization mechanism. The second approach we have is if you just want to have an automatic optimization managed by S3, you don't want to figure out your access pattern and drill down. And this might be a really good fit for many of you where you're busy with other part of the business, you don't have a dedicated infrastructure team that analyzes the access pattern, and you just want a simple way to cost optimize. And for this, S3 Intelligent Tiering is a perfect solution, where it's a storage class that automatically optimizes storage costs based on the access pattern of that data. So S3 Intelligent Tiering intelligently monitors your access pattern and move data between different access tiers on your behalf, so you don't have to worry about cost optimization. And since launch, Intelligent Tiering has saved millions of dollars for many of our customers. So given that's sort of the two approach, let's take a look at how we can apply that to Data Lake. So for Data Lake specifically, here we outline a very simplified data lake architecture where raw data flow into S3, get processed by ETL job, get put into a production environment where your analytic user then analyze or write SQL queries on top of that production environment. And then after a period of time, you put the data into archive. So for this kind of simplified, quintessential data lake architecture, how can we structure the storage classes? One way to structure your storage classes to cost optimize is to use standard or intelligent tiering for your raw data and ETL job. Because these data, you expect it to be hot data that need to be accessed quickly because they need to be processed and transformed. And then when they are processed and transformed into the production environment, you can then use intelligent tiering to automatically cost optimize based on how your users are using the data. And you don't have to worry about, is this table accessed frequently by user? Should I put it in standard? Is that table not accessed as frequently, so I should put it in a different tier? You can just use S3 Intelligent Tiering where it does that kind of cost optimization for you. Then, after a period of time, when you are ready to move the data into archive, you can move the production data into one of the storage classes, depending on how you expect that data to how frequently that data will be accessed. So let's take a quick look at what we covered today. We talked about a brief history of what led to the data lake today. We talked about the constant data explosion over the past decades that drove the evolution from initially doing analytics against production databases, which are typically transactional relational database, to the ETL architecture, then to Hadoop, then to the S3-based data lake. We then talked about some specific recommendation for building a data lake on S3, and specifically around performance. There's specific prefix naming strategy you can use to optimize for performance that add sort of entropy and randomness to your prefix naming patterns. You can also look into some of the other services like EMR or the open source table format like Apache, Iceberg, Hudi, that does a lot of optimization under the hood for you. And then we talk about the cost. Overarching, there's two strategy where if you want to really drill down your access pattern, you can leverage the variety of storage classes and the features such as storage lens and lifecycle to develop your own custom cost optimization techniques. Or alternatively, if you just want to automatically way to manage your cost optimization, you could just use S3 Intelligent Tiering as a storage class where S3 manage and optimize the cost for you. So with that said, let's go to Q&A.
Oh, wow. Yeah, excellent presentation. I know we have a couple questions. I know at least I do.
Oh, I do too.
Yeah. I think the first thing I'll ask about this is there any limitation on how large your data lake can grow on S3?
So great question. Absolutely no. So that's one of the advantage of using a data lake on S3, where you could just expect to put any amount of data on S3, and we handle all that scaling for you, so you don't have to ever worry about hitting that limit. And that's we see that as a common reason why customers transition their data lake from on-premise or HDFS to S3.
Wow, excellent, excellent.
Yeah, what I liked about the session too is just the history of data lake.
Yeah.
Right. How it's transformed over time, like kind of what it was before, now kind of what it's changed into,
Yeah.
and kind of the more value, the more open source tools that are available for customers to use. That was helpful to me. Like you always hear about a data lake, and then like, well, what is it, right? So kind of getting that definition, getting that history lesson, and kind of understanding, okay, what does the modern enterprise data lake look like today? How a customer is using it. One thing that stood out to me was S3 Intelligent Tiering came up. Mm-hmm. So I want to ask you, like, why is that such a good storage class for a data lake? What makes the data lake use case good for Intelligent Tiering?
Yeah, so great question. For a lot of the data lakes, the access pattern can get really, really complicated because today, as data lake scales, the number of user in your enterprise accessing that data is increasing exponentially. The number of objects, the number of table, the partitions going to the table, going to your data lake environment are also increasing. So it just become really, really complex to manage the cost aspect based on access pattern. And Intelligent Tiering just take a lot of that work away from you and do it on your behalf. So we really think Intelligent Tiering is a good storage class for a lot of the large scale data lakes where really like you're just busy running the data lakes. You don't want to think about the cost optimization technique, and you can let S3 handle that for you. Just a really easy way to manage cost.
Excellent. Wow. Yeah.
Got any more questions?
I have plenty of questions about this. I think one thing that since you can build your data lake on top of S3, one thing I'm curious about is like you can have a number of different services or servers or any kind of applications dump data onto S3. Is that correct? And it doesn't have to be structured or anything to create this data lake?
Yeah, great question. So no, so S3 as an object storage can handle any sort of data, whether it's structured, unstructured. As long as bytes, 0 and 1, you'll be able to store it on S3.
And I caught your prefix of 0314 in there. That was a nice little Easter egg in the presentation.
Yeah, yes, it was.
A lot of Pi iterations today,
Yes.
And then you mentioned Iceberg, Hudi, and Delta Lake. How do you work with those with S3?
Yeah. So today we see data lake are becoming increasingly mission critical. The customer demand of data lake are becoming increasingly strong, where customers are increasingly asking for more reliability, more features such as time travel, asset property, snapshots, all these features that traditional sort of a data lake stack like Hive is hard to achieve, just because Hive was designed 20 years ago. It really wasn't expecting where data lake is going today. So all these new table formats like Iceberg, Delta Lake, Hudi, they're designed for object storage, where they offer a lot of these really exciting features, such as sort of asset/transactional guarantee. ACID transactional guarantees, and also timeline capabilities, snapshots, all these very exciting features that help you run the data lake and help your analytic user that query the data to have a much better experience.
Go ahead. This is just interesting.
So, I believe S3, when it launched, had eventual consistency. It was eventually consistent. It's just the way it was designed from the get-go 16 years ago.
Yeah.
Recently, S3 launched strong consistency. Can you talk about how that changes the game for analytic data lakes? Why it makes it like S3 even better for analytics?
Yeah, absolutely. So a lot of this kind of sort of follow the last question where we're seeing increasing demand from customers where these big data applications today, a lot of them require to immediately access data right after the write. So because of that, with the launch of strong consistency from S3, a lot of customers no longer need sort of a previous workaround to sort of have that kind of strong consistencies, such as like S3 Guard or DynamoDB dependencies. So by natively offering strong consistency from S3, it really simplifies a lot of workloads for our customers since they can remove that DynamoDB, the S3 Guard dependency aspect, and also save a lot of costs because you're not running that DynamoDB, you're not running that extra secondary service. It's just a great feature to simplify and reduce costs for a lot of big data applications.
I guess I have one more question. Considering that if you have a data lake, it's a very useful, very powerful tool. How easy is it to just start a data lake? Do you have to install applications or anything like that, or you can just start putting things in S3? Can you talk a little bit about that?
Yeah, for sure. So with a lot of the managed service from AWS offer, we make it really pretty easy for you to get started. So when customers say they want to run a data lake, typically they mean a wide range of services. You have a storage layer like S3, but then on top of it you run compute. So we have, for example, EMR to do that. And then if you want sort of a data scientist environment to run Notebook, we have SageMakers. So all these tools together, AWS just offer you a very strong ecosystem to plug and play however you want your data lake. And on top of it, we'll have a lake formations, which is a feature that really help you get set up and start running your data lake very, very quickly. And we have a lot of template and a lot of documentations that help you to get started very, 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 very quickly.
Yui, one question.
Yes. What is your favorite pie?
Yeah, I'm Chinese, so I would say scallion pie.
And I just realized something too.
What's that?
314 passed and we didn't even acknowledge it.
Man.
Shame on us.
Shame on us.